Okay, for what we have in the case of number 8, all right, so we have what will be excluded from the domain. Okay, so you have x squared minus 4x plus 3 cannot be 0. Okay, for what we have in the case of number 8, it says to graph the following rational function where we have y is equal to 2x minus 6 all over x squared minus 4x plus 3. And now this is going to be a bit of a different item because this is going to be a graph that will have a hole in it. Okay, so again, we cannot have a 0 denominator, so x cannot be 1 or 3. And now this is going to be a different situation whereupon we're going to have a factor that will be shared between the numerator and denominator. And it's going to follow that in reducing. Then we have x minus 3 to cancel. And the 0 from a factor that cancels is going to be a whole. And taking what we have and reducing completely, okay, we have 2 over x minus 1. And here, okay, it's going to follow that for the vertical asymptote. This will be located whereupon we have x equal to 1. Now, in terms of looking at the degree comparisons, and taking what we have now, so you have for 2x minus 6 all over x squared minus 4x plus 3, the degree of the numerator is going to be at 1, and that of the denominator is going to be at 2. And we have the n is less than m, so we're going to have, in this case, there'll be a horizontal asymptote at y is equal to 0. And if we go ahead and look at points, that will be applying to what we have with this rational function. So we're going to have here, okay, so we have for x values, say we have, negative 1, and if I were to reduce, okay, numerator becomes negative 8, denominator is going to become positive 8. And if I have x at 0, okay, we'll have for the corresponding y value, okay, the numerator we're going to have at negative 6, and the denominator becomes 3. So we have y is going to end up at positive 2. And in the case of taking what we have for x at 2, now we have in this particular case, we have for x at 2, we have y is going to be equal to negative 2 over negative 1, which will be positive 2. And if I were to go, now we're going to have a hole at x equal to 3. And just for another point, if I have x at 4, okay, so you have 2 times 4 is 8 minus 6 is 2. And we have 4 squared minus 4 times 4, that becomes negligible. And adding 3, so you have y is equal to 2/3. So for the ordered pairs that you would have here, with x and y, okay, so I have negative 1, negative 1, 0, 2, and also, okay, make that 0, negative 2. We have 2, 2, and 4, and 2/3. Now I'm just going to mention, okay, so if with x at 3, now y will be undefined, and you would have a hole in the graph. But I just want to mention, okay, now for the completely reduced form, I had y equal to 2 over x minus 1. And this would not be a solid point, but for x equal to 3, so you have 2 over 3 minus 1. So you have 2 halves. That is equal to 1. So in this case, you would have a whole located at 3, 1. And trying to apply what we have in the graphs. Okay, so we have see if I can get this first. Okay, so you have a hole located at 3, 1. And if I plot points, so I have at -1, oops, -1, -1, and have 0, -2, also have it 2, 2. Also have 4. I'll just enter the fraction 2/3. And then equipping what we have with the vertical asymptotes. Okay, so vertical asymptote, again, we have x equal to 1. Oops. Okay, so I've already plotted the points. And just going back to the asymptotes. Okay, now I've plotted the points and going back to the asymptotes. So you have x equal to 1, y equal to 0. Again, just placing the first piece. Again, just with our plotted points. Placing the second piece, so we have one of our plotted points. So we have 0, -2. And we have checking the results. Okay, so it looks like we have everything in line. And that is correct.